Welcome, and hopefully we'll have a great discussion with more people to join, because this is a very important topic of sustainability and what 6G can do for sustainability. And, I've missed my flight yesterday, so I got here late last night, but since this morning I've heard sustainability over and over again, which I think it's a great sign that we are all committed for our journey towards a sustainable future. My name is Micaela Giuhat. I'm with Microsoft. I'm also with the Next G Alliance, which is a organization similar to HexaX, if you wish, in terms of looking for 6G and the different working subgroups that deal with things like spectrum, socioeconomical needs, sustainability as well. So very good to be here. I'm honored to have such distinguished panelists here. And I would like to start by giving you a little bit of an idea of what Microsoft is doing, because Microsoft, like all cloud providers, it's a very important piece of what the next generation telecommunications networks are looking already like and will look like. And we heard this morning from Peter that cloud was the decade factor. I love that, for 5G, and AI will be the decade factor for 6G, which is extremely interesting, and also perhaps a discussion on our sustainability journey. But let's start with the Microsoft slides, and I'll let each of the panelists introduce themselves. Hopefully they'll take a few minutes to talk about the work they're doing. Myself, I joined Microsoft about 3 years ago through an acquisition of a company called Metaswitch. We used to do and still do cloud functions, network functions. And while my background is technical, I joined the government affairs team, which is a very interesting group that does extremely interesting and challenging as well as rewarding work in terms of looking at policy and regulation for different aspects of the ICT industry. Now, since I joined Microsoft, I realized that I knew nothing about sustainability. And to be honest, I'm still learning after 3 years. And we all know that this is not really something that we have to recognize as a challenge and solve it tomorrow. It's going to be a long-term challenge, but there are things that we need to do today to make sure it's not irreversible. And while you can read this, it's a planet-sized challenge, and we all need to get our forces together to solve this. In our history, and again, I've heard this right now, a question, and why haven't we done something before? And I have to say again, learning that Microsoft has started this many, many years ago. This is the path that we have taken. And Microsoft has been carbon neutral, for instance, since 2012. And as you can see, in terms of our goals, are quite strong goals, and hopefully we will meet them, although we do have some challenges. And I'll go pretty fast through the presentation. Very happy to provide any other details after that and during the conversation. But what we figured is that there's 3+1, if you wish, things that we have to look at in the context of sustainability. And it's not only energy or carbon emission, but it's water, waste, as well as what we call build a planetary computer. Maybe it's a little bit big, but it's really about the ecosystem and the environment and how to use the data that we collect to create better ways of doing things and therefore answering the challenges that we have. For each of these things, we have measures and we have goals. And this is something that I want to address because part of the Next G Alliance work that we have done in the Green G group is to figure out what are the KPIs that we need to measure. And we've heard this morning about KPIs. Very important, because each company today has different KPIs. So if I talk to Orange, or I talk to AT&T, or I talk to T-Mobile, they will all come with different sustainability measures, which basically won't prove anything because we don't have a baseline and we don't have a common understanding, or we don't want to do that yet. So we have done this in Microsoft for many years. Actually, this year we have just published the sustainability report for last year. For instance, the Scope 1 emissions and Scope 2 emissions are going down. Scope 3 emissions are going up. Waste is going up. So there are things that we have to constantly manage, measure, and report. Water positive, extremely important to understand what we are doing with water, how much we are consuming. Water waste, for instance, in data centers have been reduced by 94%. We will be reduced by 94% by 2025. And clearly, the last thing is to digitize data to make sure that we have always information and ability to detect and react in terms of needs around the world. Same thing with waste. Waste is a big deal. And I have to tell you, it's very interesting reading a lot of about sustainability, obviously. There are 20 companies in the world that produce most plastic waste. You can look it up. They are probably the worst in terms of carbon footprint. They are probably some of the worst in terms of water usage. So it's very interesting to actually look at who's doing what and figuring out what can we do from a network perspective to enable these industries who are the biggest challengers, if you wish, for us to actually solve the issue and help them in their transformation. And with that, I would like to pass it on to my next panelist, Pernilla. It's a pleasure. And
thank you.
It's yours.
Okay, thank you. Hi, everyone. I'm Pernilla Bergmark. I work as a principal researcher for ICT sustainability impacts at Ericsson, and I'm also a co-rapporteur of Question 9 in ITU SD5, which means the standardization body which is developing the assessment standards. I think that is sufficient as an introduction of me. And I will not talk too much about Ericsson here, although we have our net zero targets in place. We have done a first halving of a mission and more than that in relation to the science-based targets and so on. But I will focus this pretty much on 6G. So my first message here today is that sustainability is not a good to have, but we, humanity, we must get our act together. And a very famous quote from the latest climate negotiation meeting is the one you see in front of you. Greenhouse gas emissions keep growing, also in our sector, actually. Global temperatures keep rising, and our planet is fast approaching tipping points that will make climate chaos irreversible. We are on a highway to climate hell with one foot on the accelerator. You may think that this was said by Greta Thunberg or some activist, but actually these were the words of the Secretary General of the United Nations. So we are in a dire situation. We already know that, but it's very clear. So before continuing, I would like each of you to take a few seconds and think about a child that means a lot to you. It may be your own child, your grandchild, a niece, nephew, or just maybe even yourself as a kid. Keep that image. So here is one of mine with a friend a few years ago in a lovely summer stay in the north of Sweden. And I think this is something that we need to carry with us, that the new moonshot target that we need to have as a sector, as a North Star for 6G development, is that we need to give our children a safe livelihood on Earth. So sustainability is not just another set of requirements. This is something that we need to frame 6G. So setting the scene a bit, our industry has already developed the trajectories that we need to follow to decarbonize. And we need to roughly halve our emissions by 2030 compared to a 2015 baseline. And our recent research, as Ericsson research, shows that we have increased 5% since 2020. So between 2015, and 2020. So we are not yet on track. And then, of course, 60 will come after 2030, and then we need to halve our emissions again. So we have a quite challenging landscape. Net zero is also a concept that is gaining traction from policymakers from all over, and expectations on the industries are raising. That goes, with example, we can see the ISO net zero guidelines that were developed and published in the end of 2022 during COP. There is also this work of the high-level expert group that was commissioned directly by the Secretary General. And they are putting quite strict requirements on companies how to decarbonize. But then, of course, sustainability is much broader than carbon only. And starting on the environmental side, we have a set of planetary boundaries. These boundaries are measuring the Earth system processes, those processes that are necessary to keep our planet stable. There are 9 of them, and we are breaching several. New work published last week in Nature shows that when these boundaries that has been known for some time are combined with criteria on both safety for humanity and justness, we are breaching 7 of them. So the challenges are immense from that perspective, but also opportunities. As a sector, if we really put our efforts to it, we should really try to make a difference. And the 60 landscape that creates new innovation platforms should really have that in mind. So with that as a backdrop, switching to the 60 more closely, we have talked about the sustainability as a triple bottom line. That means that we have the environmental perspective, which is what I focus on here, but we also have the social impacts and the economic impacts, and they will be also very important, obviously. We also look at this from the perspective of the sustainable 60 and the 60 for sustainability, so our own impact and how we impact other sectors. One way to look at that, which is commonly applied, is through the 3 orders of effects. So the first order effect, that's our life cycle impact, from the mine to the final disposal, hopefully with some recycling and reuse before that happens, and all the different activities that our products and networks and systems undergo during this period. Then we have the second order effect. That is when we use our systems in other sectors, which could bring positive effects, emission reductions, less resource use, and so on. But it could also be used in other ways that have the opposite effect, because we are delivering a general purpose technology. So what we need to do is to find ways to boost what is positive outcomes and suppress what is negative outcomes. So the first order effects, that's what we call sustainable 60, and the combination of the second order effect and the higher order effects, which is how we foster transitional changes in society and behavioral changes. That together are the 60 for sustainability area. So taking a bit of an outlook here to see what we are doing to prepare, what we need to do to prepare 60 for a 2030s world, because we are not at this point, we could know one thing for sure, and that is, of course, that 60 will not happen in the world as we know it now, because a lot of things will change. But we cannot know, but we can know some things, or we can, with high likelihood, say some things. So one thing that we can be very certain of is that the consequences of climate change, they will be worse in the 2030s world, unfortunately. And that means that we need more climate adaptation. There will also be, most likely, increasing sustainability requirements from regulators. That's what we see now. We see also that the concept of science-based targets that has really been driving the business sector when it comes to climate will drive us also when it comes to other parameters. So that starts to happen already with science-based targets for nature taking off, and we could expect probably a range of them. What we also see happening, especially on the EU side, is stricter sustainability communications frameworks. Then, of course, in other sectors are also changing, and we could help them, and we could benefit from that. But we could expect a more decentralized and load-adaptive electricity grid. We could also expect that there will be more focus on the impacts of materials, and the competition for scarce materials will grow. So that's one reason why we need to keep track of materials as 6G. And then we can see the social impacts gaining traction. They are a bit behind the environmental ones, but I think they will catch up. We know that the SDGs, as we know them, are bound for 2030, but we can be pretty sure there will be some sort of continuation or successor, but we don't know exactly what they will be. Yeah, that is a list. We can continue on it, but we shouldn't now. But it's an increasing importance of access to truly sustainable digital infrastructure everywhere. That is something that we need to take into account. And that will go for people, energy systems, the green industries, and even SMEs. And that also, we would also need to keep in mind that we need to consider this from the perspective of inclusion. It's not only in some parts of the world that we will need access to this. So I'm approaching the end of this intro remark. So I think I just wanted to comment on how I think that technology development of the different systems, access systems and telecom systems on the mobile side has evolved. So I think the traditional way have been that we have had technology challenges and even smarter systems, KPIs like latency and so on at the center. And I think we have had maybe some sustainability work historically, but it has been a bit on the side if you look at it from the technology development perspective. Then, of course, companies have worked on it and so on. But from the perspective of technology development projects, not so much. I think that we are here in the current 6G. We have improved. I think the sustainability has more attention. It's a bigger one. It has moved closer to the mainstream, and it has also been connected to it. That's what we see in Hexa-X and Hexa-X2. But I think there is still a challenge. So I think we need to move sustainability into the center, and we need to expand further. I think it's super important that sustainability is not only for some specialists on sustainability, but it's a perspective that we have in our daily work on different technology development. When we take our architecture decisions, when we think through how to signal, what kind of signals do we need, when we think through what use cases we need. We would need to put this at the center if we should really develop a truly sustainable system. So that's, in my view, how we would put the kids at the center. So I finish off where I started. The new moonshot target for the emerging 6G ecosystem is really that we should keep at the back of our mind that we need to give our children a safe livelihood on Earth, and that means that every sector needs to do its part. So it's not just another set of requirements. Thank you.
Ali.
Thank you very much. Good afternoon. My name is Ali Rezaki. I am Head of System Sustainability at Nokia Standards, based in Munich. We are developing and advancing our sustainability research from a systems perspective. Thanks very much for setting the scene and for the great presentation from Pernilla, warning us of the challenges lying ahead. I also want to stop for a few minutes and take stock of where we are today. So we are experiencing an environmental emergency today. That's clear. That's now communicated from the UN, from national governments, and from our everyday lives living through this climate emergency, and more generally, an environmental emergency. On top of that, there are disadvantaged and excluded populations worldwide. We have been hearing this in the past 2 days as well, that our technology is not, let's say, or has not been able to bridge the digital divide as it has been promised, but of course the challenge is huge. Now, against this backdrop, we are working on and researching the next generation of mobile communications. I would like to have a, let's say, I would like to step back and have a different perspective on how we can approach this challenge. By many accounts, it's been said that human nature and human disconnect has a bearing on what we are experiencing today as the climate emergency and the social injustice that exists in the world today. What does it mean? Basically, it means that we have an inability to link actions with their impact to others. That's, in more engineering terms, broken feedback loops that we have created, perhaps, or that have existed and were exacerbated with different technologies, but also, of course, social mechanisms. So, just to give an example from our engineering experience, in many projects I have worked, and let's say many of us work, I suspect, we are given certain requirements, we are given certain targets, and we do our optimizations and implementations to reach those targets. We define our boundaries, and we are concerned with what's in the boundary. But very often, some things are externalized. We are not aware fully of the implications of what we are building to what exists outside those boundaries. Now, we are, let's say, luckily being asked to optimize additional parameters. Many of us are now challenged by reducing our energy consumption in our designs and increasing energy efficiency. That's a start. And now we are asking, how can ICTs in general and 6G in particular can help rebuild that feedback loop from, let's say, what we are seeing as advancement and what we are seeing as degradation elsewhere. Now, I guess, as I said, I want to take a step back and look at it from a side view and try to understand, or let's say start investigating our impact on Earth as a whole. And what I would like to talk to you today about is a branch of science called Earth System Science. It's a holistic and interdisciplinary branch of science that involves many disciplines, from geography, from environmental engineering, meteorology, and social sciences, and it's a very interdisciplinary endeavor. And what does it try to do? Basically, it's an observation, starting with an observation, that Earth is a complex system of systems. What are those systems? We are familiar with the atmosphere, of course, where our climate emergency is taking place today. Then there is the biosphere, geosphere, hydrosphere, which we have been familiar with. And on top of that, a new sphere has been added, the anthroposphere, where all human activity is taking place. Earth system science basically explores how feedback loops within these spheres and among these spheres create stable conditions, or have created stable conditions for life to be sustained on the planet. And these stable conditions are, as we well know from the atmosphere today, are being challenged by human activity. Earth system science also has methodology to analyze and diagnose, let's say, the impact of human activity on the rest of the Earth systems. And it is basically trying to show how human activity is pushing these stable systems to their tipping points, as Pernilla also mentioned. And once those tipping points are reached, with cascade effects, there will be other stable conditions established, which are predicted not to be very accommodating to life on Earth, perhaps. Now, why am I saying all of this? Like, as engineers, we like methodology, we like analytics, and we like, let's say, data-driven approaches. And I want to, let's say, frame this as a future research stream for us. We need to understand how Earth system science can affect our research and how we can contribute to it, and basically also understand our impact not only in the atmosphere as climate change, energy efficiency, energy savings is focusing on, but as a whole to the Earth system. And why is that important? We have heard several times in the past 2 days. We have our footprint, we have our handprint, and then there is the rebound effect. We are doing a lot of innovative things to reduce our energy, to increase our energy efficiency, reduce our energy consumption. But then there is this thing called rebound effect, and then if for other reasons than our own design, consumption increases of our products, and the overall energy consumption of what we are delivering increases, then everything we have accomplished in terms of energy efficiency and savings do not produce the targeted effects. We don't have to be too dramatic, but at the end, our targets may not be reached. So, the Earth system science, can it help us to manage this complexity. Basically, if we look at this, we are operating in the anthroposphere with all human activity. And we know well our interaction between anthroposphere and atmosphere. That's what is being proven many times from the UN, from the IPCC Commission, and that link is very well established today. What about the others? Our impact to geosphere. Let's say we are happy with the electric cars, or at the beginning we were happy with the electric cars because they were zero emissions in their use phase, and we were driving them happily. Then reports started coming out about their batteries, how their primary materials are sourced. And we come to realize there is a huge impact to nature, to the land that holds those mines for the primary materials, and the forests that are being felled to open those mines. So there is a direct link now with that to geosphere and the biosphere, which includes the forests. And there is a link, a cascading effect as well, from mine opening and the forests being cut down. And then, of course, from there is a link to the atmosphere, which is basically the capacity of those forests to absorb carbon dioxide, reducing. It's a connected world, and we have to somehow find our place in this connected world as researchers, and then we have to optimize, or let's say manage our impact to this system. And I just wanted to make analogies, as we are communications engineers mostly. We are, let's say, if we take this as a network with 5 nodes and a fully meshed network, then we can say that we exist as a slice in that network. Or we can say we exist in the data flows, in the pipes between those nodes. And our actions have direct implications. But it's a complex system, that's for sure. And ESS, of course, independent from us, have developed many methodologies to manage this complexity. They use observations, measurements, and assessments. These are very close to our hearts as well. Like what Pernilla showed a moment ago, many of the standards having been developed in ITUT on environmental assessment, impact assessment, have these items. We have measurements, we have assessments. What we can measure, we measure as primary data. What we cannot measure, we assess from secondary data. So we are already approaching certain aspects of this methodology. Then ESS also uses modeling and simulations to tackle the complexity, which is another method we deploy in our work as well. So, just not to linger on, basically, if we follow such a holistic approach, we will have an inclusive perspective on not only our footprint, but also our handprint and the rebound effect. Because we will not have only considered our direct boundary, but the other side as well. Sometimes I feel that sustainability is about our impact to the others. If we think of our impact to the others, not what we are responsible for inside the boundary, then I think we we have a good chance of tackling the sustainability challenge. Then, how do we address social impact? It's a very tough question. Like in the last 2 days, we have heard some UN representatives saying that internet has failed in its promise to bridge the digital divide. Or with every next generation of mobile communications, the digital divide has been growing. We don't know if there is a causal link between that or it's just a timeline effect, that as we move in time, there are other factors affecting the digital divide that resulted in that growth. But we have to have an answer, and for that, we need to have a holistic approach as well. And I think the ESS approach could be a start. Now with 6G, how do we connect our technology to this? We create a good toolbox with what we are researching for 6G. We have heard how sensing, how non-terrestrial networks can help observe and generate time-based let's say, data that can be interpreted, and then a corrective action or any action can be based upon that. We have digital twins for simulation. We have already seen in some demos how this can be implemented for 6G. But in the report that I have reference from the German Academy of Sciences, they emphasize the digital twin for the Earth, for nature. And then if we, for example, connect those digital twins together, then maybe our simulations can show us the way before, as many of us have rightly said, it's too late when 6G becomes reality in 2030. And AI/ML has been mentioned several times. Of course, there are the upsides and downsides in terms of sustainability for when it comes to AI/ML. We have to use it with the right mindset and safeguards, obviously. Security and privacy, sensing and observations, measurements, these all involve critical data. So that's also there in 6G. I guess what we can do also is to affect Earth system science from our perspective, helping it in its methodologies. It could be a two-way collaboration. I want to conclude with this. All of what I said is highly complex, and currently it might sound a lot abstract, but as a community of researchers, not only technology researchers, but social sciences and economics included, in a truly interdisciplinary way and truly collaborative way, we can hope to start this as a community. Thank you very much.
Thank you, Ali, for Liesbet, please.
Those are panel questions. I don't think that's up to
me.
No. Yes.
Yes, here you are.
Okay, good afternoon. So my name is Liesbet van der Perre. I work for KU Leuven in Belgium. I'm currently on a sabbatical in Sweden. And I must say it's probably the best country in the world to be on a sabbatical on if you want to think about 6G and sustainability. I have the honor to be the scientific lead for two of these European projects. One is Reindeer, the other one is 6G Tandem. It is also a challenge, but I think it's equally challenging for the people working in those projects to have me as a scientific lead. Because I was invited to say a few words about what I'm doing or who I am. Well, maybe I can say that I'm a fan of Ada Lovelace. And Ada Lovelace, as you may know, was the first computer programmer, even without a computer being there. And Ada Lovelace, she believed that intuition and imagination were critical to effectively applying mathematical and scientific concepts. I would say that is also what we call engineering today, or we should call engineering. It's being creative and imaginative to effectively apply science and mathematics and physics. And she always also valued metaphysics as much as mathematics, viewing both as tools for exploring the unseen world around us. So I think she already talked about KVIs when she was working many decades ago, years ago, centuries ago. And I think that's a good thing that we also say, well, let's go back to that. But let's also be a bit maybe more creative when we talk about 6G. Now, going from 5G to 6G, what may be the difference? I know most of you, but I don't have a good view of the public. I think most of you are working somehow related to 5G, beyond 5G, 6G. So maybe who is working on 5G, beyond 5G, 6G? Raise hands. I think most of you, not everyone. And then the next question is, I won't ask you the question, but who has received this question? I have received this question quite often. Who has received the question, what will be the difference between 5G and 6G? Lots of you. And then you come up with an answer which is something you have readily available, or you try to say something you have heard from others, or you try to make up something. Well, I think what most of the answers say, going from 5G to 6G, probably this is it. We will go to something which is going to offer new services, and we think about these metaverse things, and we think about drones and whatever, and we go something which will be more sustainable, which will be more green. So I think that's a positive news that very often you hear both of them together when we talk about 6G. It's not only going to be about others, new services and fantastic scientific things, but maybe it's also going to be something which is more sustainable. Now you might criticize me and say, Liesbet, you have been very lazy because you just used the same base station and you gave it a green color. Maybe it's just been greenwashing or giving it a green color, but for the rest not doing anything. Well, it's a bit lazy, which I don't think is bad. Being here in Sweden, lagom is say you don't need to overdo things, just good enough, and maybe we should think about that. Don't overdo things, don't use more energy than is needed, don't use more materials than is needed. Maybe we should think about refurbishing as long as possible 5G from an energy perspective, from a carbon footprint perspective, from a lot of the ecological impact. Maybe we should try to refurbish 5G infrastructure at least and see how long we can keep it alive. Because this is part of a course I'm giving. It's French, but anyway, I think you can understand. And every day is a school day. If we build a computer of 2 kilograms, this is what is underneath. In resources, in materials, in energy, in water, I think it's quite impressive. So we should be aware, I think, I have a colleague at University of Lund, he put on his door, here capacity is lower than infinity. For capacity equal to infinity, contact the theological department. I would say, here, zero carbon doesn't exist. For people who want to get something, 6G that will be zero carbon, please contact the theological department. Because we know Shannon's law, and we'll say we know that capacity cannot be infinite. But let's be honest, if we know the laws of thermodynamics, and I think many of you have sometime have to learn something on thermodynamics, you will say the same thing. Zero carbon doesn't exist. I have a colleague working in the energy department. Anytime I come with, we'll go for zero energy devices, we build zero energy IoT, he says, that doesn't exist. So I think we should be careful. If we are engineering, we are not in the theological department. If we start building new hardware, we will have an impact. And just to give you an idea, if we would extend the lifetime of our appliances, like, for example, your smartphone, I'm a fan of the Fairphone, by the way, but also your washing machine, other things, or your vacuum cleaner. I don't know whether you're aware of it, but in Belgium, if you go to repair cafes, the first thing, the most things that are the most repaired thing is the vacuum cleaner. And I think even as an engineer, we are electrical engineers, suppose it's broken, and I had a problem a few months ago, and you can fix it for yourself. As an engineer, it's an existential pleasure to say, wow, I have it working again. As long as, of course, if you don't spend the money for something else. But to avoid saying, it's my excuse to buy the robot, which could work on 6G, it doesn't even need 6G. It's also an interesting idea. Maybe I can keep it alive for some longer time. So one of the things I would say, what if for sustainable 6G, instead of saying we will start deploying it in 2030, what about targeting 2033? Maybe that would be a sustainable impact. So I know that I'm not going to be, the Nokia guy is looking angry at me already. I know there is this call for sustainability projects next year of SNS. I think I just talked myself out of any project proposals by saying this. But I think we should consider it. And if we say we should start deploying it, maybe then we should do something else. Maybe we should think about what Ada Lovelace said, and she said, what are her tools and what are her values? And being more creative, being more imaginative, and what would she do? We don't know, but what if we consider the way she looked at things and maybe look a bit further than the internal things? Well, we talked about what could be the difference between 5G and 6G. Now I want to ask you, what could make all the difference if we go from 5G to 6G? Could we make all the difference? And if people ask me, what would be for you, what do you think is 6G? Honestly, I'm not looking forward to AR and XR personally. I'm not a gaming person. I get a bit sick from using some of these devices. I prefer personal contacts and holographic images, so I'm not so fond of some of the very high data rate things that are being proposed. I'm a little bit afraid of AI also. So what I typically answer is, well, I hope 6G will be what the LED lamps have been with respect to the old lighting bulbs. I hope that if 5G is still like this, we get a very good coverage, we have very good lighting, we can do fantastic things. But what we really use as an energy consumption compared to what we put in, and not only energy, but also carbon footprint in general, is extreme. So if we mind the losses of such a light bulb, what really is useful, and then, for example, of course, we can use terahertz systems and get something over the air with narrow beams, etc. But if you consider the total energy consumption of bringing things to terahertz, and the PAs that we cannot make more efficient than what they are today, I don't think physically we can go much further. The digital processing, we will be able to digital processing at fantastic speed, and we can parallelize and whatever. I agree, but think about the footprint of those things is extreme. So for me, I hope we could think in a different way. And we say, maybe we should see how we could make the LED version of lighting. Maybe it should become a big disruption. And how could we do this big disruption? Well, first of all, mind the losses. Don't only talk about energy on the air and transmit power. Think about everything before you have any energy on the air. And maybe try to build something which is much more gradual, which is built out of a lot of small things that together consume much less, and where we don't only put things there in a lagom way when we need them and only switch them on when they are needed, like these LED things that could be much more gradually switched on and switched off. And also in deployment, we don't need to put 6G there once at all. So I think there's plenty of opportunities and challenges in R&D for that. And even then, but my last slide, I see, have disappeared, but I will say, I had another slide with a lot of nice things you can do with LED lamps. And also hearing our chair saying, maybe a lot of the footprint is not in electronics. Maybe, for example, it's in the construction. Well, we're doing a project together with people who work on circular buildings and circular houses. And if they ask for sensing, they don't ask for terahertz to monitor their buildings all the time. The buildings will remain there for a very long time, for 10, 15, maybe 20 years, 25 years. And then we would need to recycle and still know what's happening. So the kind of sensing and connected sensors application they ask for is very different from what we have been talking about. So I think we can really address very important challenges, but then we should reconsider I think what are the main targets for 6G? And I would say maybe it's not the application I have shown in the beginning. Maybe we should analyze what are the tiny things, the tiny connected sensors that could make a huge difference all over and address other sustainability challenges. Thank you.
Thank you. Hi. Okay. The mic is working. Hello, everyone. I want just to begin by thank you for the organizer for inviting me to speak, and thank you, Micaela, for having me in this panel. My name is Azeddine Gati, and I am working within Orange since many, many years. I'm working since 10 years on carbon assessment, basically. Yeah? We are working on carbon assessment, and we hope the next decade, we spent like a decade working on how to optimize the carbon footprint. I hope the next decade will be how to, let's say, monetize the carbon. Okay. My presentation today, it is something about sustainability. So our talk today is about sustainability, the challenges and the opportunities. So the challenges, we know them more or less. And we are looking for the opportunities, as said by Elizabeth. Elizabeth, you said that we don't know what is the 6G. Nobody knows what is the 6G, but I know something. Following the discussion that we have during these 3 past years, it will be sustainable. I'm pretty sure that everybody is talking about sustainability. So it should be, it should be sustainable. So we have here the roadmap to the 6G. I have just 4 slides. My presentation will be very short. I have just a couple of messages that I wanted to share with you. The first one is this one, is to say that it's not late to make 6G sustainable. It's not late. I think it's not late because we did not start standardization, so we will not have people saying the radio interface is already designed, so we cannot do. The frequencies have already been chosen. It's not. By the end of the year, we have the WRC. We will fix the frequencies. So I hope we will do the good choice. So it's time. It's already. It's time to work on this, and we have the opportunity to influence. And now is the perfect time. Why? Because it's always this is what's happened for 2G, 3G, and 4G and 5G. In 5G, more not really, but in 2G, 3G, and 4G, it was the case. We designed the network and then we optimize it, and it's really horrible to optimize something that is existing because you don't have enough margin. Okay, this is my first message. The second one is something that we are working with some of you here in the audience. Is in EuCNC. EuCNC is one of the projects that we are working on with many other colleagues. So this notion of KVI, I really like it. We are moving from a world of KPIs, performance, more data rates, more lower latency, densify the connections, the capacity, and so on and so on and so on. Okay. So we know that, and we will continue that, for sure. But the other thing that we are working on is the KVI, the value. What is the value? For example, let me give you a concrete example. In France, for example, we are pushing our regulator, to stop the competition between operators, measuring what is the peak data rate. It has no sense. For some heavy users, they will need the peak data rate. But for the common population, the peak data rate has no sense. So why not working on something which is the minimum? What is the minimum data rate that everybody needed? Everywhere in every place. Okay. So changing our mindset. From KPI to KVIs. It's not simple. So KVIs can include, of course, efficiency, environment, security, resilience. Resilience is something that is really it's the hype of these two last years, especially, unfortunately, because of the energy crisis and the war that we have in Europe. But yeah, the question of resilience is really, resilience is not only energy. Yeah? Resilience, you can include security inside, and so there are a lot of things in security. So yeah, this notion of how to make the two working together. Sorry, I'm too late. Yeah, I just wanted to share this with you. This will be, it's not published yet. This is something that we are going to publish. And this is our assessment of our carbon footprint, okay? Following the GHG protocol. So you know, scope 1 and 2, basically electricity, the consumption of electricity, we know it. For example, in Orange, today we are spending like 500 million euro per year in electricity. So this is scope 1 and 2, only scope 1 and 2. And you see scope 3. Scope 3 is the biggest part, okay? I'm talking about carbon. I'm not talking about electricity, carbon. So if you have a look to this carbon footprint, you see that really when you assess the carbon, there are a lot of rooms of improvement. I mean, the carbon is not the problem of, this picture is only specific for me as an operator. Huh? We cannot say that it's the same picture for Pernilla in Nokia, or Perre in Ericsson, or in Ali in Nokia. And, I mean, OEM has, you have another picture. We have this picture, and it's continued to improve. But just to show you that, yeah, we have the carbon footprint of purchasing material, network element, purchasing services, the use of sold equipment, and the customer equipment. So you see this big, we call this the high runners, the 4 biggest parts of where we have our carbon assessment. This is to say that the carbon is not the business of just an operator with an OEM. No, it's the business of everything. For example, in Orange, our biggest part that you have, the biggest part is not the mobile. The biggest part in carbon is not the mobile, it's the fixed. Why? Because we continue to deploy the fiber. And to deploy the fiber, we have to, I don't know how to say it in English. We have to put the cables, we have to put the towers, and you spend a lot of carbon in this, okay? And also maintenance of the networks. Maintenance on the network is huge in terms of carbon footprint. We have the question of manufacturing VS usage. Of course, for an OEM, from their perspective, it's 20%, 80%, I think. 20% for manufacturing, 80% for it depends on the product, I know. Yes. For us, if we take everything, passive, active, civil works, and it's 50-50 between manufacturing and usage. But taking into account everything, okay? And yeah, I will finish just by this, but this is just an introduction to our panel. So yeah, we have to do all of this, for the 5G. Yeah, monitoring, continue the effort on monitoring, continue the effort on consuming 0 watt at 0 load. And of course, yeah, something that was mentioned, I think, by Liesbet, refurbishing and the reuse and extending the lifetime. Why not extending the lifetime? Some of the products that we have in the network, they have a duration of 10 years, something like 10 years. We want to extend it, and we want to develop, for example, marketplaces to stimulate this the marketplaces for refurbished elements. We are not obliged to buy everything at each time. We can recycle and reuse. So that was my main messages. Thank you very much.
Thank you very much. I think you have heard quite different presentations, and I'm very excited to open up this discussion because it's quite diverse, as I said. I mean, you know, from looking to the future and our kids and how to live our world to, you know, do we need 6G at all, or when do we need 6G, to looking at systems as a, you know, from an Earth perspective, to, you know, a very clear perspective from an operator on what are the needs and how their view of the world looks like from a sustainability perspective. We do have some prepared questions, but before I start, I would like to see if there are any immediate questions, burning questions from the audience. Okay, just prepare, you know, a few questions, but I'll start. Oh, there is a question, sorry. Please, go ahead. Could you please go to the, yeah, thank you.
Thank you very much, all the panelists. Very interesting discussion. My name is Konstantinos Dodini from the University of Luxembourg. I'm not sure if my question actually is directed mostly to a person coming from a vendor or a person coming from a mobile operator, maybe the latter, but anyway, anyone can jump in. So I would like to direct it actually to Azeddine from Orange. So I liked very much actually the idea that we need to focus more on the KPIs instead of the, let's say, KPIs. So instead of going to some traditional metrics like peak rate, we need to maybe mostly focus on satisfying the minimum data rate that the users actually demand. But would that mean that we need to change our mentality related to the deployment in the network, so to go to small cell densification? Because we heard in the morning from Professor Rappaport about going to higher frequencies, so that means we will need to go to a highly densified network. So, I mean, how does it play out, I mean, with respect to the energy efficiency? Because, I mean, in my view, at least correct me if I'm wrong, actually densifying the network with small cells, so nodes that have active components, power amplifier, means that we will, let's say, induce a very high energy consumption. So we need to plug this, actually. I mean, who, let's say, is going to pay the electricity bill, plus actually all the energy consumption, the CO2 emissions, not only about the energy consumption, but also aesthetically means, as you said, about the carbon, the CO2 actually that may come from, let's say, that they need to dig, actually, to install cables. So we need to power those nodes. We need to create power cabinets. We need exactly cables for that. Even if we don't go underground, if we go with over-the-air cables, still aesthetically, it will create something that is not sustainable. So it's not about the, let's say, carbon footprint. It's also the aesthetic means. So sustainability is also about the aesthetics, not seeing everywhere cables and stuff. So, I mean, mainly that, actually, how this idea of small cell densification is compatible with the fact of, let's say, sustainability, energy efficiency, etc. I mean,
can I try to do the question? So I guess your main question was that cell densification actually could lead to increase energy consumption, and is that a good thing or not, and are you taking that in consideration?
Yeah, let me give you a concrete example, okay? In France last year, we were obliged by the government to extend the network by 1/3 because we want to, for inclusion, even for white spaces, what we call white spaces, I mean, spaces where there is nobody. Okay, you can increase, you can accept to increase the power consumption. You can accept, we have to accept it. I mean, it's not a problem. I mean, we are deploying networks to connect people, and we have to accept that there will be an increase in terms of power consumption. But then the question is how to manage this energy. I mean, you can, for example, generate green energy by solar panels, for example. You can activate on this by densification. You densify, but you deploy sleep modes, for example, to make it to put it in a dormant mode when there is no traffic, and other many other levers. So there is no opposition, I think, between densifying and increasing the power consumption. And as I said, things are not opposite. Really, you don't have to think it like this. Think it in the way that sometimes you have to accept you increase the power consumption, but sometimes it's not. I mean, it's not. For example, let me give you an example, horrible example. Base stations which are installed in stadiums. Okay, why they are always on? They are always on. We have a football match 1 per 2 weeks. Okay, why they are always on? Because we don't know how to switch off a network. We don't know how to do that. We can activate some sleep mode, but we don't know how to switch it off completely.
May I jump into that? So I think on a technical basis, the good thing is if we go for cell-free networks, which is one of the technologies for 6G, and we start thinking about how we could build those, I think there's plenty of possibilities to do much more gradual sleep down and sleep up. And I think we should consider that in the system design up front, that part of the thing would be in the system to make sure that you can switch it off to a large extent in a lot of situations, in different places, at different moments. I think that is part of how 6G could do much better than 5G, is if you design upfront knowing that very often you want to switch off part of it, and the cell-free concept, I think, is very well supporting that. And then the hardware should also support that you can switch it off, that it's not like it's on or off and you have to wait 5 hours to get it on again, that you have all kind of sleep modes in the hardware that the system level can incentivize this and vice versa. I think that's one thing. Another thing I want to fight a little bit, I think it's not because it's been said this morning that we should always go to higher bandwidth and therefore to higher frequencies. That is a given thing for 6G. And I think we have also seen presentation by Nokia that the golden frequencies maybe are the ones that will be best serving like the digital inclusion and covering with the white spaces and what on. I would avoid that we say, well, let's immediately try to deploy the very high frequencies that need a very dense deployment everywhere. I think that is not a given thing. You kind of stated like this is the vision, that's what we should do. I think it's more correct probably to say let's do that on places where there is a capacity shortage where you need a very high throughput. But for the white spaces, as you've been talking, I would not go to sub-terahertz, to be honest.
Thank you very much for the question.
Thank you.
Yeah, please go ahead.
I think we are missing something here. In 5G, there was a big step toward reduce the power consumption. If you know, the Shannon law says whenever you have more bandwidth, it's linear with the capacity. Whenever you have a SNR, it's a log with the capacity. So by the regulator, which gave us more frequencies, actually, for the same capacity, if you look at that, in order to achieve capacity at a certain bandwidth today, we are doing QPSK 60 QAM, 64 QAM to 56 QAM. If you go for QPSK to 64 QAM, it's almost 20 dB in the power. But if you give me 4 times the bandwidth, it is just 4.
Yeah,
so
but
it
that
is like
is
100 to
No, but that's
10.
the metric of transmit power. But if you look at the efficiency, before you make it, I think a typical power amplifier today at very high frequencies, if you achieved 15%, that's a lot. So we should
I'm not talking yet about the high frequency. I'm talking the...
Yeah, but that's the point also with bandwidth. I think we should be careful.
I will come to that. When you go to the high frequencies, okay, still, if you do densification, then most of the time you have line of sight. Again, you transmit, instead of 12 dB per double the range, you are doing 6 dB double the range, you're getting less capacity. So as far as the technology in 5G, we did a lot of steps to move forward in this. The regulator is helping us, give us more bandwidth. So today, I can tell you for sure, we are almost for the same data rate, same throughput, we are almost 10 times more efficient than the 4G that is only 20 megahertz relative to 100 megahertz bandwidth.
Can I be provocative?
So we are not so bad in situation. Yes, we have
I think I will be provocative. If you go for the high speed, yes, but the 0 watts, what do you say, 0 watts, Liesbet?
0 watt, 0 watt.
I think for zero load, we have been getting to something which is much worse than before. For the maximum, and I'm a massive MIMO addict, I think for the high loads, I agree with you, but for the zero loads, 5G is worse than 4G. And in a lot of situations, we are far from the maximum load. We are into not the zero load, but closer to the zero load. And then, unfortunately, 5G is worse than 4G.
I agree with that. If you don't have capacity, okay, you don't need to transmit, then don't transmit. It's okay. I'm not argue about that. But again, I'm talking about because when we are going to 6G, we want more capacity. It's not zero load. So that's the situation there will be. So that's what we have to think.
Thank you very much. I think that's a very good point, though, to remember that XG actually brought a lot of efficiency gains. And it's not all very, it's not very bad from an ICT industry where we stand. So where we stand is that we are 1.5 of the total carbon emission and perhaps 3 or 4% of the energy consumption. So from an ICT perspective, I think we are pretty good in our standing. That doesn't mean that we don't have things to do. And I just want to go to perhaps the first question that we had prepared in terms of the challenge, but I want to frame it in a way that I think of a challenge. So given that I'm from Europe, but moved to the US for many years now, I realize that money, 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 it's not just a song by ABBA, but it's actually what makes the world go round. And in terms of really challenge and perhaps a response is that we need to make things affordable. We need to make 6G affordable. Not only for the consumers, but for the people that make the equipment, for the people who provide the service, for the people who don't have anything. And that's the only way, in my mind, you can do that. It's to rely on innovation. That's what we have done. All our lives, in all our history, we haven't stopped the consumption. In fact, consumption actually goes on, and that's a challenge to the Earth theory, because I don't think it's a loop issue, broken loop issue. It's more of a fact that we don't put what's the right loop, and the loop, it's, we do something for something, which is money, and then it goes back. Does it make money? We do it again. Does it not make money? We start something else, right? So from that perspective, I would like to frame the challenge and ask each of you, what do you think the challenge is for 6G? And maybe I'll start with you, Pernilla.
You mean from the monetarian perspective?
Well, I thought that's the biggest challenge.
Okay, that's the main challenge.
That's my perspective, but maybe you have a different one.
No, but I would probably say, in line with with my presentation, that it will be the integration of sustainability perspectives and the technology development, that we are not really there, and we are coming from quite different perspectives. And maybe the question we had over there, which had maybe to do a bit with things like, or thinking like sufficiency and that kind of, I don't know, concepts or that we are used to be a sector which is aiming for faster, slower, you're aiming for the extremes in performance. But in reality, in 6G, we would need, I think, from a sustainability perspective, much more of flexibility, and also to have the full life cycle perspective. And to get that, we really need to integrate the technology knowledge with the sustainability knowledge.
Okay, thank you. Ali, what do you think?
Thanks for the great question. For me, having lived through the generations of mobile technology, I think our biggest challenge is managing complexity. And complexity results in all sorts of impacts, and one of them might be cost, one of other is accessibility for industries, for individual operators, but also verticals. That is also a challenge for sustainability. And like in the engineering world, it's over-engineering complexity. And in the standards world, we have to get 6G through. It's about addressing every single option, every single, let's say, requirement, turning it into a design, and more and more of what we are building into the specifications is excluded from everyday usage. We have some statistics, but sometimes it's perhaps even 10%. So why is that complexity there? And that adds to cost, that adds to the, let's say, zero load energy consumption. We have to manage complexity, I would say.
Thank you. Very, very interesting answer.
Yeah, very quickly, two points. The first one, I said it, as an operator, we don't know how to switch off a network, and we want to switch off. We want to have the ability to switch off. I mean, it's not normal that we cannot switch off. We can have partially a switch off. We call this the deep sleep, but we cannot sleep. So I mentioned this point. I think in the next generation we need that. We need this flexibility. The second point is something that we work with Pernilla, is the LCA, life cycle assessment. We will ask. I mean, we signed with the Dutch Telecom and Orange. We will at each time we will buy something from this year. We will ask for an LCA for every single product that we buy. An LCA means an assessment of manufacturing, usage, end of life. Okay, but we need the two first because these are the biggest. We want to simplify the process for this. It's too complex, the LCA. The life cycle analysis of the product, I mean, we cannot compare it for the moment. I mean, I cannot say this one is better than this one because this carbon footprint of this one is better than this one because the assessment still, there are still complexity. So I hope I hope we will simplify.
Please go
May
ahead.
I comment
Yes.
on that?
You want to react? Yes.
No, yeah, I have a mic. So the life cycle assessments are complex because they are modeling something complex.
Yeah.
And the only way to make it simpler and especially to make it comparable is to develop specific scenarios. And that means that the results that you produce, if you simplify, the results will be less accurate. And if you create comparable conditions, that means that you will get the comparability, but at the same time, the results will be less specific to the conditions that they are modeling.
Yeah.
So it comes with a cost, but it's possible, and that's why we are working on it in EuCNC and ITU. But we should be very aware of the limitations, and it's not LCA is a bad methodological approach, but it's an important one. If we will understand things at depth, then we will need to do studies at depth.
Thank you.
Any comments?
Elizabeth?
Yeah, but coming back to the business model question, I think that is a huge question for IoT. For example, we could develop very novel things to have IoT supporting circular industry, which is, I think, for a lot of more ecological impacting industries a very important thing to go more circular. And we could define new IoT networks and solutions to support that. But where is the business model? Currently, people have said IoT is a 0 billion market. And I think, how could you, for example, have incentives for saying, suppose I put connected sensors and in 25 years from now, when something needs to be recycled or could be reused, I will be able to tell you what it is and where it is. Where is the business model? I think that is a huge challenge.
Thank you. I agree. And let's, although it's all very interesting and very true problems, and going from very concrete to putting networks to sleep or thinking about the complexities. I want to turn back to you and see if there are any other questions. Please go ahead.
Hello, thanks for organizing this very interesting panel and your talks. yeah, talking about refurbishing, I was thinking of generations of networks like 2G, 3G, 4G, 5G. Now we talk about 6G, but 5G isn't there yet. It's not deployed fully yet. And then now, okay, another layer of network that we talk about and deploying it. And should we think about a new, like a much more different way of deployments, like instead of this traditional way of network deployments, where you need to, it's a cellular-based deployment where you need to put a cell and it has to cover all around this, wide coverage, whatever, like, the way we calculate even coverage and the performance of a network. I mean, even the regulations pushing like operators to cover, I don't know, 99% of the area versus the population and so on. I mean, with a new generation, do you really need to do that? Then what happens to the sustainability? I mean, you have to produce all this equipment, buy that, I mean, and have to cover all over the place with this new 6G. Or do you foresee like a new way of network deployments? Like, can all these networks, are we going to throw away all these? No, we never do that. They are going to stay. Of course, we always talk about backwards compatibility. They are going to be there, of course. There is a lot of redundancy here, first of all. Is it sustainable, really? It's a very basic, sustainability issue that, we are creating a lot of redundancy, first of all. I mean, we shouldn't, I think, talk about 6G as a single, alone solution. We should look at our networks. Now, we already created a lot of redundancy. What are we going to do with this existing, network, first of all? What do you think about that? And on top of it, what is going to be the 6G? How should we approach this network deployment problem now? Are we going to do the same mistake again and again in every 10 years? That's my question. Thank you.
Thank you very much. I think it's a question that I always have. So just 2 seconds. I come from a telecom background. I joined Microsoft, and I said, look, every network has to have 5 nines. And they look at me, it's like, what's that? Right, so it's all this redundancy that we build. You have to have 4x basically, because you have local redundancy and then you have geo redundancy and you have all that and you build, and it's a huge cost. Now, having said that, I know that the wireline networks have consumed a lot of energy and still consuming, and operators like T-Mobile have actually gone from wireless completely to actually virtual wireline to actually virtual wireline services. So they removed all the switching gear that consumed quite a bit of power. Having said that, so we are making positive steps by going to the next generation networks, but it's a very valid point that you also brought up that, perhaps we do need to think more about refurbishing. So,
may I?
Please.
Yeah. C-check. Be careful about the false good solutions. Let me give you the example of 2G, 3G decommissioning. Okay? If you decommission a network, okay, you have to ensure that people who are only, because there's still, that are only 2G, 3G. They have mobiles which are only 2G, 3G. You have to migrate them to 4G, okay? When we do the assessment, that's why I'm saying that the carbon footprint is the essential thing, okay? We have to evaluate the end-to-end, okay? The gain that we have lowering the energy consumption by decommissioning the 2G and 3G was completely compensated by the carbon footprint of migrating the people from 2G to 3G with the handsets. Moving from because you have to fabricate, you have to manufacture new devices. So you have to, and you have to take it into account. So there is a kind of a balance between the two.
But that's exactly what she's saying. Why should we go to the next generation when we have a perfectly, or if we go to the next generation, should we think about completely new design as opposed to going through the next 10 years of 3GPP development? Please.
So I don't think I have any answer to that, but I think that is exactly the kind of conversations that we would have if we put sustainability as a center. And I think you know, as engineers, when we are developing something, there are a lot of boundaries. We try to optimize something within a boundary. And when we add the sustainability perspective, and not only the energy consumption, but the materials consumption to this equation, we get yet another boundary that we need to optimize towards. And when we start doing that, we will ask new questions, we'll probably come up with new solutions, and that will be new innovations. So I think that what you asked here, yeah, maybe we should do it in another way, or maybe we are doing it in a good way, but we need to tweak it a little. But it's exactly the kind of conversations that we need to have.
Yeah, I also indeed agree. This has to be looked at in a holistic way. You know, we are not only working on carbon emissions, but we are also working on circularity. And in standardization, but also in research, there are several steps before, let's say, equipment can be decommissioned. You can remanufacture it, refurbish it, and then at the end, if nothing can be done about that, then it is, let's say, recycled. Then, of course, we have the analogy from the light bulbs. When at home you replaced your incandescent light bulbs with LEDs, or in between you used the fluorescent bulbs. What was the motivation? And indeed, as we include new parameters into the equation, we try to optimize them. And Azeddine brought a very good point. We cannot only think of the network. We are now trying to understand the network enablement effect for UEs, but also data centers. So end-to-end, this is, there are lots of things to consider. And hopefully in the 6G transformation, this will have been researched enough, and that transition will be managed in a much better way.
Thank you. That's any other great questions, please come. We still have a couple of minutes, please. Maybe this will be the last question, depending on the time, but please go ahead, thanks.
My name is Jos Perre, working for TNO Netherlands. I have a question for the panel, because there was like a red thread hearing that the terahertz and the power amplifiers can do so much in terms of efficiency. I recognize that there's a limit there. And then we could hear from Orange that there are some challenges in switching off to do so, and then to go about it, to calculate or to have some measure. Then we could hear in terms of we should build scenarios to, well, to have a better view, to be able to better compare. And now the question comes, okay, good, how to build such scenarios? Because what I've seen, let's say, with other topics in the past, if you are too early, they are all over the place. We're still in the vision phase. We don't have a clue what 6G will do. If you are too late, there are already vested interests. So some scenarios are more important, let's say, for certain parties compared to others, because they had to make themselves decisions. So then you get stuck, and there's very hard to reach consensus. How can we do that? Or how can we go about with 6G that we don't get stuck in either approach, let's say, too early or too late?
Thank you. Thank you, and please go ahead. I don't know, let's start from you,
I
Liesbet,
think many years ago, and Louis was there, we had the Earth project where a lot of it started with analyzing what is the situation. And this is an unfortunate situation that I have colleagues, for example, not from my university, analyzing carbon footprint and so on. It's very difficult to find funding for analysis work. You have to show that you're going to change the state of the art and that you bring a contribution into innovation. And so if you see evaluating project proposals, what are all the questions you get? If you say, I'm going to build a model that allows to compare and to assess, it would be very difficult to score on any of these things, even in getting papers accepted. It's very difficult to score if you say, I'm going to bring an analysis that points this out. So I think we should somehow also as academics and scientific people reward that just clarifying the full problem and trying to make these models and comparisons of total impact is something we should value better, I think.
Well, quick one, because we have only 6 seconds left. Each of you. Go ahead, Ali.
Yeah, thanks. I think this has come up several times during these days as well. While when 6G deployments will be only beyond 2030, how can we do assessments today? And the role of simulations, digital twins, this has been emphasized, and it is indeed the case. And for sustainability as well, we should use these opportunities and embed these into our research projects. Every technology has the life cycle as well. We start with, let's say, theoretical research. We move to an applied research phase. We use the POCs, and then we have the standardization, then implementation and deployment, and decommissioning, etc. So we are in that process somewhere in the research phase, moving into, let's say, proof of concepts, as Peter was saying this morning. So indeed, we have to be mindful of where we are, but use simulation as a key opportunity.
Yeah.
Thank you. We are at the end of the presentation. I'm sorry not to give you a chance to respond, but I think I want to thank all of you for staying with us and listening to us. And if you have any questions for the panelists, please approach them, and have a great rest of the day. Thank you so much.